Okay, so for number 6, I'm just going to write down the question here. It's m to the power of 4n squared plus 4m squared n plus 4. Okay, so when I look at this, again, I see 3 terms, and first and last look square rootable, so that's what I'm going to do. I'm going to square root the first, and I'm going to square root the last, and take the sign from b. This is what we call, again, a perfect square trinomial. And so we have a process to follow when we have perfect square trinomials. It is just literally squaring the first and square rooting the last, and then writing a squared on those 2 terms and take the sign from b, right? So we're going to get m squared n, and the square root of 4 is 2, and I take the sign from b to be plus, and we square it. That's our answer. Number 7. We get a simple trinomial here. So y squared minus 13y plus 42. Okay, so we're looking for, this is a simple trinomial. Again, simple because the coefficient in front of the y squared or x squared term is 1. Okay, and so we're going to go, I'm looking for 2 numbers that multiply to 42 and add to negative 13. Okay, so we can run through 142, 2, 21, 3 and 14. Okay, we're still not there yet. Then we look at, okay, 4 doesn't go into 42, so we're going to skip it. 5 doesn't go into 42, so we're going to skip it. But 6 goes into 42 7 times. So we've satisfied the multiplication condition. Now, additionally, we have to make sure that we check the addition condition as well. And 6 and 7, so 6 plus 7 is 13, but that's not the condition we're trying to make. We're trying to make negative 13. And so if I were to make negative 6 and negative 7, that is negative 13. And coincidentally, when I multiply negative 6 and negative 7 together, I still get the satisfaction of positive 42. Okay, so those are our 2 factors, and we like simple trinomials because as soon as I do that, or with a simple trinomial, as soon as I find the 2 numbers that end up working, I can just write the variable in front of them. So here's our answer. This does not require the decomposition process. Okay, that's it. All right, number 8. Number 8 is a bit of a jumble, but not bad, something you've seen before. So I'll just write out the question. 5x plus 10 minus 2z minus zx plus 5y minus zy. So upon initial study of the question, looks like something you've never seen before, but what we can always do is it doesn't matter what order we add and subtract things in. Same with it doesn't matter what order we multiply things in, right? So we can shuffle this question around and group things that we think are like have something in common. So the way I chose to group these terms, these 6 terms, I group them based on divisibility by 5 and divisibility by or common factors of z. So what I'm going to do here is just going to rewrite this whole question so that it looks a little bit better. So 5x, I'm grouping by divisibility by 5 here, plus 10. That takes care of that, and the 10, which leaves 3 terms left. Coincidentally, all 3 have z's. So minus 2z minus zx and minus zy. Okay, from here, we're just gonna factor by grouping. Okay, so I'm gonna factor the first half, the first three terms separately from the last three terms, and see what happens, right? And you remember, in order for this to work, I have to end up with two of the same thing on either side, or either piece. Okay, so what I see here, all three are divisible by 5. So I'm gonna remove that 5 out, and I'm gonna get x plus y plus 2. Okay, and then over on the right, it looks like negative z. You'll notice all three terms have a negative on it. So I'm gonna remove that negative z from the question, and I'm gonna write what's left. So I have 2 plus x plus y, and you'll see the negatives turn into these two negatives turn into positive signs because I've divided each term by negative something. Okay, almost there. You'll notice that these two things are actually the same. They're just written in a different order. So what I'm going to do is just factor it out as something that's common and write what's left, right? So I'm going to factor out the yellow piece, right? So I'm going to get x plus y plus 2, right? And when I remove it, I'm going to get 5 minus z is what's left, okay? This is what we know as factoring by grouping. Okay, a little bit of a lengthy question there, but not bad. Okay, number 9. Number 9 is x squared plus xy minus 12y squared. Okay, again, a little bit more complicated, but it's still a trinomial, and specifically it's a simple trinomial. We just have a little bit of an altered process to factoring this. Okay, so what we're going to see here is I'm looking for two numbers that multiply. Now, one thing to note just before I write this down, x is the variable in this question. Everything else is kind of a part of the numerical portion of this, if you will, or the conditions that we're trying to satisfy. So x squared plus x signifies that this is a trinomial, and then the rest is just extra. So what I'm going to try and do here is satisfy the condition. We're trying to multiply two numbers together to give me negative 12y squared. That's the last term. And I'm trying to satisfy the addition condition of just y. Okay, so I'm going to ignore the x squared and x because they're kind of marking the fact that it's a trinomial. Okay, so I'm looking for those two conditions. So we could try, this one's a little bit trickier to explain, but we know I would maybe ignore for now the second, just as a tip for you. This is just two numbers that multiply to negative 12 and add to 1. So 1, 12, 2, 6 is still not going to add to 1, 3, 4. Interesting. Okay, so we can try and force that to work. I'm just going to bring back the condition of y there because that's what we're trying to satisfy. So I would start with the numerical portion of this, questions that look like this, and then tack on that extra little piece, right? So what I see here is 3 times 4 doesn't multiply to negative 12 or add to 1, but I could make one of them negative and satisfy the conditions. Right? So if I, let's say, made the 4 negative, negative 4 times 3 is going to be negative 12. That's good. But negative 4 plus 3 is negative 1. That's not the condition I'm looking to satisfy. I need to satisfy positive 1. And so I know that I can make the 3 negative as well. Okay, so those are the two factors that satisfy the numerical portion of this. And then what I'm gonna check or try to force to work now is if I'm still multiplying, if I tack the variable back on the y, negative 3y times 4y is indeed negative 12y squared. And if I were to add negative 3y plus 4y, that satisfies that condition as well. Okay, so a little bit of a trickier question from that standpoint. Maybe something you haven't seen before, or we have, or just forgot about it, but a little bit trickier. Okay, but it doesn't change the fact that it's a simple trinomial. As soon as you found these two factors that satisfy your conditions, as we've done, you get to write the variable, in this case, x, in front of those two factors, right? So this is us almost done. Okay, that's us done. That's the answer. Okay, one more for this video. This is questions 6 through 10. Okay, so I'm gonna write out 9x squared plus 2x. Sorry, 27x plus 8. So you'll notice it looks a little bit different, okay, than anything that we've seen so far on this review sheet. And it looks different because that number is not 1. Okay, and so we said we had a special classification. This was a complex trinomial, which requires us to use a process known as decomposition. Okay, and basically we're taking something and we're going to decompose it into two pieces, but we need to figure out what those two pieces are first. Okay, very similar to simple trinomials, just one alteration to the process. So again, we're looking for conditions to satisfy our man method. Now the tweak here is when I'm checking the man, it's not just the last number anymore. It is, well, it's always, in fact, the a value times the c value. It's just with simple trinomials, it's coincidentally just 1, and so it's always 1 times 8 in that particular instance, but in this case, we're gonna be 9 times 8. Okay, so the condition that we're trying to satisfy is the fact that we're trying to multiply to 72 and add to 27. Okay, and the best strategy I found for this, at least for me, was running through the conditions. So 172 is obviously never going to add to 27, so we skip it. 2 and 36, okay, also multiplies to 72, but it's not going to satisfy our addition condition. So we go to 3 times 24 gives us 72, and it also adds to 27, which is what we're looking for. So those are our two factors that satisfy these conditions. Now that's us kind of found the conditions under which we can use the decomposition process now. So as I said before at the beginning of this question, decomposition, okay, we are breaking down something. What we're breaking down is this middle term into 3x plus 24x, right? 3 plus 24 is 27. 3x plus 24x is 27x. And then I just write the other two pieces. And we're almost done. So what we're going to do now is use our factoring by grouping process or skill set, right? To break this question in half and remove common factors across each half individually. And then we're almost done. Okay, so across the first half, it looks like I can remove a 3x, and then I'm going to write what's left after I've removed it. So 9x squared divided by 3x is going to be 3x plus 1. And what's common across the second two terms? It's 8. So I'm going to write 3x plus 1 again. Again, with our factoring by grouping process, we should expect to see these two things, these two factors come out to be the same, and if we've done it correctly. Okay, so we see that is the case, so now I can write 3x plus 1 multiplied by what's left is the 3x and 8. That should be your answer on your sheet.